Hey, time to tear this apart. And yes, you've probably seen a video on this one done before. But I decided to buy one a couple years ago. I've taken it apart. I looked inside. I did up the schematic. And then I went, oh, I should actually do a video because it's kind of funny how the schematic goes. So I reassembled. And now it's time to tear it apart. The first thing goes, lose that part. Get out trusty screwdriver. And I will show that this does work, though other videos have shown that it works. Let's pop this apart. There we go. Comes apart nicely. You've got your nice little carbon thingies on this end. Now I am going to show that it does work, and I will have to adjust the lights. I'm going to use a power bank. I am not plugging this into my computer. Now let's just see. Turn off that light. Turn off that light. Get it into the shadow. Pull out one of these nice little neon bulbs I've picked up a few years ago. Bring it close to it. It lights up. Actually, that's quite noticeable. A lot better on the camera than in person. So, now that I know it works, what I'm going to do is try not to zap myself. Take it out. And now, turn some lights on. Let's just move you to the side for a second. Okay. So on the top side here, we got one capacitor, an LED, a transformer, and the whiskers. And short it all out. Okay. There we go. So you got the oscillator on this side, you got a feedback winding, and a few components. You've got this resistor here going from the high voltage side to the low voltage side. And then you've got 4 diodes, 4 capacitors. Hey, this looks like whatever, I'll show you the name, / Walton voltage quadrupler. Now, of course, we want negative on this side. So here's the schematic on it. Excuse me. Everything on this side, over this way, is basically from there over. It's got a small decoupling capacitor, then the main capacitor here, the LED, and a little resistor coming down 1,000 ohms to show that it's actually plugged in. It's got a J3Y NPN transistor. And also they've got, for the oscillating, they've got a feedback in here. I'm not sure which way it's hooked, but it's probably up this way. And then you got your primary coil and your secondary, with a lot more windings than the primary. Then they've got a 20 meg resistor right there going across. And they've got actually a fair size gap in there for voltage isolation. Now, normally you'd be going, okay, it's one of these here. This, of course, is for positive, and that's a pretty standard circuit. For negative, all you do is you reverse all the diodes and point them the other way. That's not what's in here. What they have in here is, okay, it's starting to look, but wait a second. Shouldn't that connect down to there? Now I'm going to have to try to get this focused in. I might just take a picture. Okay, let's see if you can see it. For the first one, it's clearly connected down into here. But if you look up here, wait a second, the track goes straight across between those two capacitors. It's not connected there either. Not sure how well you can see that, but I did also meter it. And then instead of going on here, where they should be taking it off of, well, there actually is a spot where there's where they could have put a probably a 0 ohm resistor, and then there's a hole there, and they could take it off. But no, they stuck it way over here onto this one. And I think what they did was, when they originally built it, because they've put all the components on this thing, they're not trying to skimp on a component. They put this one, they tried it here, and maybe it was just too good and causing a few problems with other electronics that you plugged it into. So they dropped back the amount of voltage coming out here by putting it there. And I'm not sure, because I can't measure this thing with any of my meters. Yes, I have a disposable digital multimeter, but I'm not sacrificing it. So the circuit's right, except it's not connected there, which kind of makes this that, hey, if I actually connect this bridge here, and I'd probably be able to do it fairly easily, just put a big bunch of solder right there, and then I could actually move this over to here. This thing should be able to produce that full power. I think that's worth a try, and I'm not plugging this into my computer. Best it'll get is a power bank or just an adapter. So let me do that. So I'll just bridge that gap there. Oops. Yes, this gap. Not the prettiest. Yeah, that looks like it should work. And then I'll take this off. Whoops. There we go. I had to edit something. Apparently YouTube doesn't like you burning yourself. I'll take that off of there. And then I'm just gonna solder it right there. You still running? Yep, you're still running. So, I've now got all that hooked up. This should be interesting. Flip that over. I'm going to turn off the lights, and I've got only a few more seconds before I hit the 10-minute mark on this camera. And it didn't work. Okay, it's still set up as a negative voltage multiplier. I've got the bridge there. It doesn't work yet. It does start lighting up over here. So I'm wondering if the transformer in here had too many windings for their design, and what was happening was they're overloading the last diode. So I'll just hook up to, there's the ground. Yeah, you can't see it. Okay, let's try this. Ground over. Oh, nice arcs. Yeah, I'm not getting a proper voltage off of this. Let me zoom down a bit further. If nothing, we can see a nice arc. But I bet you that's what the problem is. So, there's the ground. And I'm looking at the meter, which seems to peg and then stop. So I'm betting this last diode, the voltage on it's being exceeded. It does work if you connect it up here, but it doesn't work if you connect it up over there. Comments, I'm not 100% sure, so if you've got an idea, stick it in the comments. Have a good day. Bye.